Welcome to our comprehensive guide on highway materials. In this video, we'll explore the essential tests used to evaluate aggregates and bitumen, the two fundamental materials in road construction. Understanding these tests is crucial for ensuring the strength, durability, and safety of our highways. Whether you're a student, engineer, or just curious about how roads are built to last, this video will break down each test, explain its purpose, and walk you through the key steps. Let's get started by looking at why testing highway materials is so important and how it impacts the roads we use every day. Aggregates form the backbone of any road structure, providing stability and strength. To ensure they meet the required standards, several tests are performed. These include the Aggregate Crushing Value, ACV, Test for Compressive Strength, Aggregate Impact Value, AIV, Test for Toughness, Los Angeles Abrasion Test for Hardness, and more. Each test targets a specific property, helping engineers select the right materials for different layers of the road. In the next scenes, we'll dive deeper into each of these tests, starting with the ACV test. The Aggregate Crushing Value, ACV, test measures the resistance of aggregates to compressive loads. This is vital because aggregates must withstand the weight of vehicles and traffic over time. In the ACV test, a sample of aggregates is placed in a cylindrical mold and subjected to a gradually increasing load. The amount of crushed material passing through a specific sieve is then measured. A lower ACV indicates stronger aggregates, ideal for high-traffic roads. Let's see how this test is performed step by step in the next scene. To perform the ACV test, start by selecting aggregates that pass through a 12.5 mm sieve and are retained on a 10 mm sieve. Fill the cylindrical mold in 3 layers, tamping each layer to ensure compaction. Weigh the filled mold to get the initial weight. Place the mold in a compression machine and apply a load of 400 kN at a rate of 40 kN per minute. After loading, sieve the crushed sample through a 2.36 mm sieve and weigh the fines. The ACV is calculated as the percentage of fines to the original sample weight. This value helps determine if the aggregate is suitable for use in road construction. The Aggregate Impact Value, AIV, test evaluates the toughness of aggregates, or their ability to resist sudden shocks and impacts. This property is especially important for road surfaces exposed to heavy or fast-moving traffic. In the AIV test, aggregates are subjected to repeated blows from a standard hammer, and the resulting fines are measured. A lower AIV indicates tougher aggregates, which are less likely to break under impact. Next, we'll walk through the detailed steps of the AIV test. To conduct the AIV test, select aggregates passing the 12.5 mm sieve and retained on the 10 mm sieve. Fill the cylindrical mold in 3 layers, tamping each layer. Weigh the filled mold to record the initial weight. Place the mold in the impact testing machine and deliver 15 blows from a height of 380 mm. After the test, sieve the crushed material through a 2.36 mm sieve and weigh the fines. The AIV is calculated as the percentage of fines to the original sample weight. This value helps engineers assess the suitability of aggregates for use in road surfaces. Beyond ACV and AIV, several other tests are crucial for aggregate evaluation. The Los Angeles Abrasion test measures hardness and resistance to wear, ensuring aggregates can withstand traffic-induced abrasion. Specific gravity and water absorption tests determine density and porosity, while shape tests like flakiness and elongation index assess the suitability of aggregate shapes. The soundness test checks resistance to weathering, and the stripping value test evaluates adhesion with bitumen. Each of these tests contributes to selecting the best aggregates for durable and safe highways. Bitumen acts as the binding agent in flexible pavements, holding aggregates together and providing waterproofing. To ensure its performance, several tests are conducted. These include the penetration test for consistency, softening point test for temperature susceptibility, ductility test for flexibility, and viscosity test for fluidity. Additional tests like flash, fire point, specific gravity, float, solubility, and durability, loss on heating, assess safety, purity, and aging resistance. Let's explore these bitumen tests in detail, starting with the penetration test. The penetration test measures the hardness or consistency of bitumen, which affects how it performs under different temperatures and loads. In this test, a standard needle is allowed to penetrate a bitumen sample under a fixed load and temperature for a set time. The depth of penetration indicates the softness or hardness of the bitumen. Softer bitumen is used in colder climates, while harder grades are preferred in warmer regions. Next, we'll look at the step-by-step procedure for conducting the penetration test. To perform the penetration test, heat the bitumen sample and pour it into a container, then allow it to cool. Maintain the sample at 25 degrees C. Place a standard needle on the surface and apply a 100-gram load for 5 seconds. Measure the depth the needle penetrates into the bitumen. This value, expressed in tenths of a millimeter, indicates the consistency of the bitumen. The test helps engineers select the right grade of bitumen for different climatic and traffic conditions. The softening point test determines the temperature at which bitumen softens, which is crucial for understanding its behavior in hot weather. In this test, a steel ball is placed on a bitumen-filled ring, and the assembly is heated at a controlled rate. The temperature at which the ball touches the bottom is recorded as the softening point. The viscosity test, on the other hand, measures the fluidity of bitumen by recording the time it takes for a fixed volume to flow through a viscometer. Both tests help ensure bitumen will perform well under varying temperature and traffic conditions. Durability is a key property for bitumen, ensuring it resists aging and retains its binding ability over time. The durability, loss on heating, test involves heating a thin film of bitumen at 163 degrees C for 5 hours, then measuring weight loss and changes in properties. Other important tests include flash, fire point for safe heating, specific gravity for density, and float, solubility for consistency and purity. Together, these tests provide a complete picture of bitumen's suitability for road construction, helping engineers build longer-lasting, safer highways. In summary, thorough testing of aggregates and bitumen is essential for constructing durable, safe, and cost-effective highways. Each test, from crushing and impact to penetration and durability, plays a vital role in material selection and quality control. By understanding and applying these tests, engineers can ensure that our roads withstand the demands of traffic and weather for years to come. Thanks for joining us on this journey through highway material testing. Stay tuned for more insights into the science behind the roads we travel every day.